In this video, we're going to look at another example of centroids and moments. The question here is to find the centroid of a region bounded by the curves y is equal to root of 3x plus 6, y equals 3x, y equals 0, which is just the x-axis, with linear density, rho is equal to 3. We start by sketching the bounded region. So what we have is we have y equals 3x. Let's solve for x in terms of y, because we're going to be drawing our slice horizontally. We're going to be doing all the centroid formulas in terms of y and not x. For this reason, we need to solve for x in terms of y. So divide by 3 both sides, and we get x is equal to y over 3. And we have y is equal to root of 3x plus 6. If we solve for x in terms of y, we'll get x is equal to y squared divided by 3 minus 2. Now sketching this is pretty easy. If you're sketching y equals root 3x plus 6, the easiest way is to find this intercept, make the inside of the radical 0, 3x plus 6 equals 0, solve for x, we get x equals negative 2, that's the x-intercept. To find the intersection points, you will have to make 3x, y equals y. I haven't done this here, haven't shown the work for that, but I'm sure you'll be able to do that. Square both sides, do some algebra, and you should find the intersection point to be 1 and 3. All right, so we have x in terms of y, the right function, f of y, so x equals f of y, is equal to y over 3, we call this the right function, and then the left function is x is equal to g of y, is equal to y squared, divided by 3 minus 2. And our goal is to find a centroid of the region bounded. All right, so let's apply the centroid formulas in terms of y. Mass is equal to rho, the density, integral from a to b. These are y limits, f of y minus g of y dy. And this is the horizontal area element, which is f of y minus g of y dy. This is equal to, density is 3, integrate from y equals 0 to y equals 3, and the right function in terms of y is y over 3, so x equals y over 3, minus the left function, which is y squared, divided by 3 minus 2. Integrate with respect to y. So we get mass is equal to 3 times integral from 0 to 3. Let's simplify the integrand. We get y over 3. Distribute the minus sign, we get minus y squared, divide by 3, and also multiply negative 1 by negative 2 plus 2. Integrate with respect to y. So let's now carry out the integration. Integral of y over 3, reverse the power rule, add 1 to the exponent, divide by the same. Y squared, divide by 6. Minus y cubed, divide by 3 times 3 is 9, plus integral of 2, antiderivative of 2 is 2y. Evaluate from 0 to 3. Now let's put the upper limit in. 3 squared is 9. Let me write this as 3 times. So let's not forget about the 3 in the front. So 3 squared is 9 over 6. Putting the upper limit in, minus 3 cubed is 27 divided by 9, plus 3 times 2 is 6, minus 0 plus 0, that's all 0. So the mass is equal to 3 times 9 over 6, this is 3 half, minus 27 over 9 is 3, plus 6. This is equal to 3 times 3 half, 6 minus 3 is plus 3. So we have 3 times 3 plus 3 over 2 is simply 9 over 2. And we get 27 over 2. All right, so what we have is the mass is equal to, the mass of this region is 27 over 2. If we decimalize that, we get 13.5. All right, let's look at the formula for the moment with respect to the y-axis. This is going to be rho times integral from a to b, 1 half, right function squared, so f of y, all squared, minus left function squared, g of y, all squared, integrate with respect to y. Okay, so moment with respect to the y-axis is equal to density, which is 3, integrate from 0 to 3, these are of course y limits, 1 half, times right function squared, so that's y over 3, all squared, minus left function all squared, y squared divided by 3 minus 2 all squared, close off the bracket, and integrate with respect to y. 1/2 is a constant, passes through the integral, so we get moment with respect to the y-axis is equal to 3 over 2, integral from 0 to 3. Let's simplify the integrand so we can do the integration. Y over 3 all squared gives us y squared divided by 9 minus y squared over 3 squared gives us y to the 4th divided by 9, folding out the inside the brackets, and we get minus, the middle term is minus 4 y squared divided by 3, and a minus 2 all squared, that's plus 4. All integrated with respect to y. Moment with respect to the y-axis, simplifying further, we have 3/2 integral from 0 to 3, y squared divided by 9, minus y to the 4 divided by 9, plus 4y squared divided by 3 minus 4, close off the bracket, and integrate with respect to y. So the moment with respect to the y-axis is equal to 3/2. Now let's integrate term by term. Integral of y squared over 9, reverse the power rule, add 1 to the exponent, divide by the same. We get y cubed, divide by 3 times 9, 27. Reverse the power rule, integral of y to the 4th over 9, add 1 to the exponent, that's 5, divide by 9 times 5 is 45. Plus 4y cubed, divide by 3 times 3, that's 9. And antiderivative of negative 4 is simply minus 4y. Now apply the fundamental theorem of calculus, put the upper limit in and the lower limit. Moment with respect to the y-axis is equal to 3 over 2. Putting the upper limit, we get 3 cubed, that's just 27 over 27, simplifies to 1. Minus 3 to the power of 5, divide by 45, that gives us 243, divide by 45. Plus 3 cubed is 27 times 4, that's 108. Divide by 9, minus 12, subtract, and put 0 in, it's just all going to be 0. If we simplify these fractions, we get minus 33, divide by 5. And if we decimalize this, the moment with respect to the y-axis is minus 6.6. All right, let's now find the moment with respect to the x-axis. The moment with respect to the x-axis is equal to density, integrate from a to b, these are y limits, and we need the distance to the x-axis, which is measured by the y-coordinate of the horizontal element. So that's y times f of y minus g of y dy. This is a formula, centroid formula in terms of y for the moment with respect to the x-axis. So the moment with respect to the x-axis is equal to density, which is 3, integrate from 0 to 3, y times f of y is a right function, x in terms of y, we get y over 3, and g of y is a left function, y squared divided by 3, minus 2, close off the bracket, integrate with respect to y. So moment with respect to the x-axis is equal to 3 times integral from 0 to 3, y times y over 3, we get y squared divided by 3 minus y cubed divide by 3, and minus times minus is plus 2 times y, we get plus 2y. Now that we have simplified the integrand, we can do the integration. Moment with respect to the x-axis is equal to 3 times, integrating y squared, we get y cubed, divide by 3 times 3, that's 9. Minus y to the 4th, reversing the power rule, divide by 4 times 3 is 12, plus integrating 2y, we get 2y squared divided by 2, the 2's cancel out, gives us y squared. Evaluate from 0 to 3. So the moment with respect to the x-axis is equal to 3 times, put the upper limit in, we get 27 over 9, minus 3 to the 4th, that's 9 times 9, 81, divide by 12, plus 3 squared is 9, minus 0. If we decimalize this, we're going to get the moment with respect to the x-axis. I should say if we add up the fractions, we get 9 minus 243 divided by 12 plus 27. Multiplying this 3 through and simplifying. So adding and subtracting these fractions, we get 63 divided by 4. And if we decimalize this, we get 15.75 for the moment with respect to the x-axis. All right, so the whole point of this question was to apply the centroid formulas, but in terms of y. So that was the only tricky part of this question. And it's good to do at least one or two of these, just in case you see it on a quiz or an exam. So mass is equal to, we found the mass of the region to be 27 over 2. We found the moment with respect to the y-axis to be equal to minus 33 divided by 5. We found the moment with respect to the x-axis to be equal to 63 divided by 4. So we found the mass, we found the moment with respect to the y-axis, and the moment with respect to the x-axis. Now we can apply the formulas. X bar, the x-coordinate of center of mass, is moment with respect to the y-axis divided by the mass. This is equal to minus 33 divided by 5 divided by 27 divided by 2. Let's flip the denominator so we get minus 33 divided by 5 times 2 over 27. If we simplify this, we get minus 66 divided by 135, and decimalize it, we get approximately minus 0.49. Now y bar. Y bar is equal to moment with respect to the x-axis divided by the mass. We found the moment with respect to the x-axis to be 63 divided by 4, divided by the mass, 27 divided by 2. So we have 63 divided by 4. Flip the denominator, 2 over 27, and simplify, we get 126 over 108. Decimalize, we get approximately 1.17. So the centroid is x bar is equal to minus 66 divided by 135. This is the x-coordinate of the center of mass. Y bar is equal to 126 over 108. This is the centroid. Let's show this on a diagram. Let's go back to page 1. So we can see that we have the x-coordinate of the center of mass is minus 0.49, so that's roughly about here. And the y-coordinate is 1.17, so about here. So there it is. This is the center of mass right here. And that's where the center of mass of this object is, of this plate. All right, thank you.